Everyone. Thank you so much for joining us to this second day of our Fundamentals of Soil Health workshop series. We're very happy to see that a lot of folks that joined us yesterday are coming back today. But for those of you that couldn't make it to day one, the videos will be available for you. I guess I should introduce myself first. My name is Miguel Garcia, and I'm the Sustainable Ag Program Manager for the Napa County Resource Conservation District. And today, we're very happy to have a list of very interesting talks with very smart and very kind speakers. And for our first section, we're gonna be talking about floor management. And our first speaker is Bill Birmingham. Bill is our conservation project manager for the Resource Conservation District, and he focuses on erosion and floor management. So that's what he's gonna be talking to us today. Bill, thank you so much for joining us. Let me go ahead and stop my screen and go ahead and share your screen, Bill.
Got it?
Perfect. We're looking at the website, right?
Yes.
Okay, go ahead, take it away.
And you can hear me okay?
Yes, we can, thank you.
Okay. Good morning, everybody. As Miguel mentioned, my name is Bill Birmingham. I'm the Conservation Project Manager here for the Napa County Resource Conservation District. And today what I'm going to try and distill for you all is a discussion about ways for you to quickly and easily model your soil loss using a fairly common and simple equation. It's called the universal soil loss equation. Everything that I'm talking about today is available to you, including the Excel spreadsheet for you to do the modeling on your own, as well as the guidance form that I'll be walking through the model with you on today on our landsmart.org website. If you go onto this website and then just click on resources and then go down here to plan templates and reference guides, you'll find the Excel spreadsheet as well as a PDF of the guidance form, which is here, and this is what it looks like. And it's basically a 6-page form that'll kind of walk you through everything that I'm talking about today. Just a couple quick things on this form. This first link here in the first paragraph, the predicting rainfall erosion losses, that is a link to the scanned copy of the original Universal Soil Loss Equation manual. I believe that manual came out sometime in the 40s. It was originally began in the Corn Belt and in about 1940, and then further updates continued through about 1965. And so this publication has those updates. And then this second publication that we have a link to is Guides for Erosion and Sediment Control in California. So as most of us know, living in California, we have our own special concerns and requirements. And so this form really helps with situations that you might be interacting with here in California. I like this one quite a bit because for us as the Napa RCD, we would use these USLE calculations to confirm quality control of proposed erosion control plans for vineyard developments in wildland settings. And with the original publication, we weren't really able to be able to fine tune our cover, percent cover and current situations of these wildland settings, say for example, an oak woodland or a conifer forest. But with this California guide, we were able to do that. So that guide really gets you into the nuts and bolts of different ways that you can kind of tweak the model for yourself. And that form, I think the last update for that was 1996. It's pretty classic. Both these are basically scanned copies that you'll find on the internet, and you'll see actually hand-drawn strike throughs on different sentences and handwritten edits. So that's about as good as it gets for stuff that kind of came out pre-internet. And we here at the Napa RCD have used it and interacted with the county planning department as these as a resource of these forms, and they find them to be applicable. So I believe that the literature that's in there is accurate. As far as, again, kind of continuing with the history of USLE, it is now more commonly people will use what's called Russell II, which is the revised universal soil loss equation. I don't have a lot of experience with it myself because I found that model to be limiting in those wildland settings. So I often use the original model and then this California guidance guide to be the most applicable. But what else would I say about Russell 2 is, I think that's about it. So that is available. It is an update from USLE, but again, for this presentation, USLE is a pretty quick, straightforward program. I believe that it's got good news and bad news related to it. The good news is, I think it's a real quick guide in order to show you how your management practices, and if you change those practices, how they can relate to increasing or decreasing soil loss. I think the bad news to the model, or the shortcoming of it, is I wouldn't take the numbers that it produces as actual what's occurring on your property. It's just more or less a way to gauge what you're trying to achieve and how your management practices are influencing that. So we'll kind of continue and move through on that. So the universal soil loss equation, which is again is available on our website, is an Excel spreadsheet, and hopefully you all can see it here on my screen. And it basically asks you to input a series of numerical values, and it will give you an answer which is considered as A, which is soil loss in tons per acre per year. And so what you need to do for this equation, first off, is kind of figure out the area that you're in and what T is. And T is a value that's been assigned to every soil type within the United States by the U.S. Department of Agriculture. And T is basically the soil loss tolerance, and it denotes the maximum level of soil erosion that will permit a high level of crop productivity to be sustained economically and indefinitely. Again, T is very similar to A, in which it's measured as tons per acre per year. So that's the main thing we want to get at here. Currently with the Napa RCD working in the Napa River watershed, we have a new permit from the Regional Water Quality Control Board for vineyard properties, and the Water Board is asking to ensure that the property manager's soil loss rates don't exceed T. So this value of T, or tolerance, is still relevant today. So we've been spending a lot of time using this equation to help folks understand where they are relative to that compliance requirement. So I wanted to take an example property for you. I just found this hillside vineyard property somewhere here in Napa County. This is a very, this is a theoretical situation. I've never been on this property. I don't know who owns it or what their management practices are, but enabled to use ArcGIS and see the aerial imagery, I felt like it would be able to suffice for us as a good example and play around with some of these equations in the universal soil loss equation. One other thing I'd like to note as far as this T value, which is the soil loss tolerance, and then the A value that we're getting, which is the tons per acre per year of what's actually happening on the ground. So what is a ton of soil loss? What does that look like, you know, over an acre of property per year? And so quick little like Google question, what does a ton of soil look like? All soils have different bulk densities, and so a ton of soil of one soil type might be a larger volume than another. But just in the nutshell, the quickest definition that I was able to find was that a plow layer, which is about 6 inches deep, is about 1,000 tons of soils over an acre. So if you were to lose 1 ton of soil, it's basically 6/1000ths of an inch of over soil. So hopefully that helps you, give you a visual conversion from tons to what that might actually look like out on a property. So so back to our scenario here. We've got a vineyard block here outlined in purple, and this is sort of our area of interest that we want to look at. And back to our equation, you know, the first thing we want to do is find out what our T is. I've already given us the soil type because I was able to find that. So we're looking at an Aitken loam that exists on 15 to 30% slopes. But what you can do, and again, the guidance walks you through this, is basically you go onto the web soil survey, And this will help you to achieve some of the, or derive some of the values that you need to put into your equation. Web soil survey, if you haven't spent a lot of time here, I think Evelyn talked about it a little bit yesterday. It's got a ton of great information. I will say that, you know, this information is at a 1 to 24,000 mapping scale, so pretty high up, sort of bird's eye view. May not necessarily be as accurate as you need on your particular property, but it gives you a good starting point, and it's free. So I encourage folks to go onto this website and look at their area and see what information is currently available to them. You can zoom into the area that you're looking for, either using the magnifying glass or sort of double clicking in different areas. But what I like to do is I like to import an area of interest, or the AOI, because I use ArcView GIS. I'm able to do that with the shape files that I have. So let's see if this works out for me as well as I want it to, because it has in the past, but now that I'm doing a presentation, let's see what happens. So these shape files that I'm using ArcGIS, when you open them up in Windows, they actually end up looking as a bunch of smaller files. So that was the shape, and then we'll do the SHX in here. And then finally the projection, or the PRJ. And then we'll hit set AOI. And there we go. So if you see here, let's see if I can back out a little bit. Don't think so, but this is basically our same property that we're looking at here. So that was how I was able to do that. There we go. So back to our web soil survey. So now we have our area of interest, and we can start getting some of the data that we're looking for to fill out this Excel spreadsheet. So we go to the Soil Data Explorer, and we want to look at some soil properties and qualities. And again, this is all written up for you here in this guidance table. So you can always come back and refer to this. And what we're looking at is we're looking at the erosional factors of the soils here. So we're going to click on this menu. In our spreadsheet, first off, we want the T value, which is the soil loss tolerance, which I described briefly. But we're also going to need this K value, which is basically the U.S. Department of Agriculture has said, what is the potential for that soil to erode? So its erosiveness, or its ability, ability to be transported. So what we're going to do is go back here and get those two values. So here's our K value. Rock-free would mean is if you had sifted your soils and removed all the native rock materials. We're going to assume that that was not done, so we'll use the whole soil. And then we have our T factor here. And so basically what you can do is click on this drop-down menu. If you click on View Description, it describes what the K value is. If you view Rating, it's going to give you your soil types. Down here, it's going to show you how much of your area of interest is covered under that soil type. So we got 93% and 6%. And then for our soil type that we're looking at, it's giving us a K rating of 0.24. We find this oftentimes in hillsides in Napa County, where some of these soil types, the USDA has not given it a K value because maybe it was a rock outcrop or something like that. We do have, and it is identified in this guidance form in that California publication. Well, for Napa at least, we have K values for all of our soils that came out. It was a table that came out in like 1988, so we will reference that. So I really don't have a workaround for that. If the web soil survey doesn't have the K value, you'd have to go to some other resource and get that for yourself. But for this presentation, we'll just use this soil type, the Aiken loam, and with this K value. What's nice about this is you can do a printable version. It'll convert it into a PDF, which I've already done. And you can keep this PDF. It has the map view with your soil types, kind of has more of a description of what it's giving you, and then gives you that table again. Here again. Oh, actually, it's interesting. In this PDF, it does give you the K value for both of them. Huh. Anyways, so back to the web soil survey. So we could do that for our K value. And then we can also get that for our T value. And we would do View Rating. And scroll down, and it gives us our T of 3. gives us how much of that percent of area of interest. And again, you can get a printable version, save that as a copy. If you're submitting these modeling to other agencies, it's nice to show your work. So it's always good to keep those copies. So let's go into our equation. Let's start putting in some numbers here. So we've determined that there was a T of 3 from our web soil survey, and our K value was a 0.24 from that other factor that we were able to derive. But, and so look down here, we can see our tabs that we have here that are gonna help us fill out some of our information. So rainfall, which is identified as the R value, is basically you're gonna look at the 2-year 6-hour storm event, and you're gonna determine how many inches of rain would occur in this area for a 2-year 6-hour storm event, and that's gonna give us an R value. Again, that's a internet function that we would be working on, and what you do for that one, and again, it's written up in the web guide, is NOAA Atlas 14. So this gives you rainfall data. This one, again, you can kind of double click here to get to your area. You can do some other ways of putting in the information, but for me, because I've got my GIS layer up, I can just basically get the lat long here and put that into my data. And so it's interesting with GIS, kind of opposite what the website wants. So go here. See. Submit. Boom. Takes me my area of interest. You can kind of zoom in if you want to and see more precisely if incorrect, that is the correct location that you're looking for. And then as you scroll down on this website, here's your durations by year. So this is a 1-year storm event, 2-year, all the way up to 1,000-year. And then this would be the durations or the minutes, then you get into hours. And so back to the spreadsheet, we are looking at the 2-year 6-hour storm event. That's the data we need. So we go 2-year 6 hours, so that's 2.33 inches. And so we would come back to our table here. 2.33 inches is about 100. So we'll just keep it there. If you wanted to round up just to be more conservative, that would be fine. So we'll go back to our table here. So R is 100. So there we go with that. So you can do this. I'm gonna, I have this ability to do this on GIS, which is a very powerful tool, but it's also a very expensive tool. You can also do these in Google Earth Pro, but basically the next factors that we want to get for our table is the slope length, and then what the percent slope is, and that's going to give us what's called the LS factor. And so if we look here, we sort of, what we're doing here in this table is showing our work. Again, if we were to present this to another agency and they wanted to see how we derived our numbers, they can see this, how this table works to give us the LS factor. So when you put in slope length and the percent slope, it basically calculates the LS. So it's going to be the R, the K, and the LS multiplied together. And these two values are just giving you that LS. So I hope that makes sense. As we continue to work through this equation, just kind of pay attention here. We've got our T value now identified as a blue bar, and the actual soil loss of the A is going to end up showing up over here as a red bar. And hopefully on your computers, you'll be able to see that difference more clearly. So with GIS, I have a measuring tool that I can use and click on. And basically what you want to do when you do your slope length is you want to determine which way the water would flow across the landscape. So I use a 5-foot contour interval, and I just try and look at how water would sheet down. This would be my more upper elevation. So that's my 1460-foot elevation, and then down here, that's a 1362, so that's downhill. So upslope, downslope. Basically for this vineyard, it's a pretty straightforward, almost following the vineyard rows parallel. And so you can just basically, what we do is we look at the outside edge of the upper perimeter avenue all the way down to the outside edge of the lower perimeter avenue. That gives us about 724 feet. That's our slope length. I think for my equation, because I've done this before, we all got together, I just said 720 just to make it a more rounder number. And then to get percent slope, see, there we go, our red value starting to, our A is starting to show up here. To get your percent slope, it's that age-old equation, rise over run. So you would take the difference in elevation from the top of your area minus the difference of the elevation at the bottom. That'll give you the total difference in elevation, and then you divide that by your length, and that will give you percent. I've already done it for the sake of this project, and I think what I came up with was about 12% slope. I think it was like an 85-foot vertical difference between the two. So boom, wow. So that shoots it up pretty high, but we're not done yet. The next two factors that we're going to look at is C and P. So C is your cover factor, and this is basically the percent cover that you have on your property, and then also with your practice, your tillage practices. So it's the rows are tilled or your non-tilled rows. And then for here in California and for vineyards, oftentimes folks will do alternate row tillage. So you can just take, if you had 70% cover for your tilled and 70% for your non-tilled, you could take the difference between those two values, and that would give you your value if you were doing alternate row tillage. And then P, which is your practice, is basically the orientation of your vines relative to your slope, and take into consideration how steep that slope is. So for this scenario, our vine rows are up and downhill, and our slopes are about 12%. So it doesn't matter how steep your slopes are. If your vine rows are oriented up and downhill, you're always going to have a 1. But then if you have terraces or cross-sloped vineyard, you can play around or get these different values, which is a value less than 1. And so let's go back to our table. Our practice is 1 because our vine rows are in fact up and down slope, as we can see here. Oops, sorry about that. Going back here. And so cover. So I haven't been on this property, so I just wanted to kind of play around with some cover values that I thought were applicable to a lot of the properties that I interact with, and then will kind of help us play around with this this model. So what is cover, though? Let's kind of hold the brakes on that and sort of define that, because we're asked to put in just one value for that. So here's an example of what a cover value would look like if you had a smaller tape measure or transect on the ground. These folks out here, they basically ran a tape across a section of ground. They put a pin in every 4 inches, and the greenish blue pins that land on any sort of cover, whether that's living or dead cover, the pin gets that green blue color, and if the pin lands on bare earth, it gets a red color. So of these 10 pins that are 4 inches apart, 2 of them landed on bare earth. So that's 80% cover. Does that make sense? 2 out of the 10 get dirt, so 80% or 8 pins have good cover. So looking at our vineyards, we tend to generalize what the cover would be within the vineyard planted area and give that a value. And so this is an example of a vineyard block where they're strip spraying under their vines, and then they have cover crops in their middles, which is the area between the 2 vines. And so let's just say, for the sake of math and to make this fairly easy, these vine rows, let's say they're 10-foot spacing. Let's say that the strip spray from the vine to the outside edge of the middle right here is about 1 foot, and that would be on either side. So that's 2 feet of strip spray. Oftentimes in the strip spray areas, we see very minimal or no cover whatsoever. So 10-foot width, 2 feet of no cover, so that's going to give us about an 80% cover value, just as an example. Here is another example of a vineyard that's got strip sprays, but we can see that our strips are much wider here. Let's, again, just for the sake of argument, assume that this is a 10-foot wide spacing of our vine rows here. And so, you know, maybe our strips here are 2 feet wide here and then 2 feet wide here. So we're really looking at about 60% cover here, assuming that we've got about 100% cover happening within the growing vegetation. So strip spray width can play a lot into your overall cover values. Just want to kind of point that out to you. And then here we've got another vineyard that has no strip sprays and has really good cover coming in to the vine row middle. So we're looking at more like 100% cover value here. Something about cover and tillage practices. Oftentimes when I come out to folks' properties, let's say it's the end of the year, October, they're implementing some tillage practices. And so when we say, oh, well, you're supposed to be, you're here in Napa County, hillside vineyards have what are called erosion control plans, and that erosion control plan will state what sort of cover value they're supposed to be achieving. We assume, as well as the regulatory agencies, and agree with that, we're looking at what your cover value would be once the property starts to receive rainfall amounts that promote germination. So it's really basically your seeding practices and your strip spray widths that are really going to help you achieve those cover values. Here in California, what we assume is that the first few rainfall events don't produce runoff. And what they're doing is they're soaking into the soil and helping get this cover germinated. And so basically what we're saying is, what's your cover going to be like at the beginning of the wet season? So this example, this property, they've been tilling on their perimeter avenues as well as in their middles, but they've also seed drilled everywhere. And so this is sort of that beginning winter. All their cover crops are starting to come up and germinate. And so they're maybe looking, we can still see some bare soils in here, but they were probably pretty clean looking towards the end of the season. And now that the rains have come in, they're getting more towards that 75%, maybe 80% cover value. That is assuming if people are seeding. Not all properties are doing that. And so here we have an example of a property that I was able to view off a county public road. This is February, and we can just tell here that they're really getting any germination at all. So they're really not achieving any cover during the winter time. And so in this type of scenario, it would be difficult to give them a higher cover value, thinking that they would achieve that with wetting rain. So I think it really does come down to the component of, are you actively seeding to achieve the cover that you're looking for? And finally, this is another property. This one, this photo was taken before harvest, but still really late in the season. I don't know if you can see it, but there's some bird netting here that's still protecting the clusters. They haven't harvested yet. This is not coyote poop. This is probably some cluster thinning that they were doing, but really late in the season. California, oftentimes we don't get any rains. This year was really dry, but after April, and then we're harvesting in October, September, sometimes some months of dryness. But due to their vineyard floor management practices, they're not strip spraying, they're not tilling. They've got a really good grass component, maybe a couple little weedy species, but just a really nice vineyard floor from an erosion control soil health perspective. These folks are ready to go. I mean, if that first storm event that came in was significant enough to produce runoff, they would be really stabilized and ready to go for those wetting rains. And with this type of setting, you would also assume that they probably waited to mow their cover crop till after the cover crop went to seed, so that they've now got a seed bank that's ready to germinate and come up once those wetting rains do come in. So those are just a couple examples of cover. I did spend a lot of time on cover in this equation because I believe it's an important factor, and it's also one that can be manipulated quite well by the property manager. So let's say for this property that we're looking at in our scenario here, back to this vineyard property, let's just plug in, let's assume that they are tilling all their rows and that they are achieving 75% cover with wetting rain. So that's going to give us a value of 0.045. Oops, sorry about that. So 0.045. And so you can always put notes in here if you want to. You just say 75% tilled, kind of let you know what you're doing. And so now we've got all our factors in here. One other thing I kind of want to mention, and I apologize, I should have mentioned this earlier, is the R factor. Again, back to that, you know, that's regional based upon where you are. And for this property, we had 2.3 inches of rain. And, you know, again, that's a 2-year, 6-hour storm event. So that's really defined as, I would say, as a moderate storm event. It's kind of giving you a more easygoing scenario. You can definitely see here that if you get into higher intensity rainfall events, that R factor would go up quite a bit. But this is more so what we're modeling is if you were to look out the window, you would say, yeah, it's raining outside. It's not like you would have a debate with somebody whether it rained or not, or if that was a heavy mist, or it's not on the other extreme where you would be thinking about loading a chainsaw into your car before you tried to get out your driveway to see if any trees had blown over during that storm. So it's not a really high intensity storm, but it's definitely, I think for most farmers, they would say a 2-year, 6-hour storm event was a good wetting rain. Where we are here, you know, 2.3 inches in 6 hours. That's not uncommon for this hillside area in Napa County. So they do get a lot of rainfall up there. So I just want to kind of go back to that, that R value, that it is really what we're modeling is a moderate storm event, and what type of soil loss would we have during that moderate storm. So basically what we've got here now is given these parameters, about 75% cover, no till. With our rainfall average, we have about 5 tons of soil loss per acre per year, and our T is at about 3. So there's 4 things that we can play around with here and try and alter our management practices and see if we can reduce our soil loss. One of those is, you can kind of tell here that in the equation, some of these numbers are whole values and some of these numbers are percents. And so anytime you multiply something by a decimal place number or percent, you're going to reduce that whole number. So practice is 1, so it's not really increasing anything, but it's not really helping to do or decrease anything. So, you know, what we said here was our vine rows are up and down slope, and we had about a 720-foot long slope run. So that really influenced the slope run really, and the percent really influenced the LS factor, which is a whole number. So you could think about, well, what if I changed my slope direction from up and down slope, and let's say I did cross slope, and then you can look at cross slope till versus no till, or cross slope with alternate tillage. The other factor that you can play around with is your slope length. You know, you have here, like we said, it's about a 720-foot run down through our vineyard, but we've got a interior avenue going on through here. What if we converted that avenue into a ditch and then ran that ditch where we could basically cut our slope length in half? And so you could run that, and then basically about half of your slope now that you would have running. And so now instead of one long run of 720 feet, you could have 2 runs of, what is that, 360 feet, something like that. So if we put those in, let's see if we can, let's see if I wrote down those numbers to do that. We could put in that inboard, or put in that cross slope ditch. So that would be 360. So we're basically cutting the slope in half. And then we're doing a practice of, let's go in here and say we're going to go with cross slope tillage 0.75. Oh, excuse me, 0.8. 0.8. So we've decreased our A to below what the T is, which is what we wanted to achieve. 2 things with that, though, is that that's a pretty costly practice. You're basically looking at replanting the entire vineyard to do cross slope vines. That's probably going to also have an influence on your solar aspect of your vines. More often than not, folks here in Napa want to plant up and down slope because they get better even solar exposure to their vines. So that would have a further economic decrease for your property in the long run. And then if you're going to think about doing a diversion ditch through here, you now have to mitigate your flows when they exit the property. So whenever you put in a diversion, into a vineyard, basically what you're doing is you're taking sheet flow and you're concentrating it into a ditch, and then you're concentrating it into a single outlet. And so in between these two blocks here, what you can start to see here is we've got some sort of swale-like feature that looks like it's probably developing into a class 3 stream. So if you did put a divergent ditch here and outlet it here, then you would have to design some sort of retention basin or T-spreader so that you're not increasing peak flows and causing erosion down through your stream channel. So yeah, that's another cost to your project, and you would have to have that T-spreader or that retention basin somewhere within the existing footprint of your vineyard, which would further decrease the area you can plant. So you could play around with those, but they're costly. That's something that you would have to do pretty far out, and so probably not the best thing to think about at this point. So, but I just wanted to show you that that is a way to help reduce soil loss, decreasing your slope length, and doing an orientation of your vine rows. But maybe more so, what's something that we can do on more of an annual basis, and luckily for us, this is basically covered in one table for us to kind of play around with, and that is looking at your cover values and how your tillage practices go. So right now we said 75% cover in a tilled scenario, and then let's keep that cover value the same, and then let's just kind of go from a full till setting to a no till, and then even look at maybe an alternate row tillage and see what that works with this on. So we're still getting about the same amount of cover, but maybe we'll start reducing how much areas we till. So if we did alternate row tillage with 75% cover, that would give us a 0.034 value. It's getting us closer, but we're still a little bit above that T value. So let's say we went to a no-till system on this property, still achieving 75% cover. Now we're about a half a ton below that T value. So we're definitely doing a lot better. Again, T is the max. So anytime you're close to the max, you're still kind of redlining it with practices. So just kind of keep that in mind. So let's go back to our original scenario. That's 75% cover with all till in all the rows. And so that's getting us back to that 5.05. But let's keep going with tilling everywhere, and let's just try and increase our percent cover either through our seeding or reducing our strip sprays. And let's say now that we're going to get 80% cover out there. So that's 80% cover. And so sorry, that scale the scale kind of freaks out a little bit over here, but getting closer to 3. And then let's bump it up to 85%. Oops, sorry about that. 0.22. This is 85% cover would give us that value. And now we're below that T. So those are the things you can kind of play around with. I think it's a good idea to be able to know what that T value is based upon what the U.S. Department of Agriculture has told us, and then sort of look at what we're doing with our practices on the property and how we can get this AA value below that. Again, these aren't absolute numbers. I don't think this is really what's occurring out in the field, but it's a great way just to show you how your practices can influence retention of soils or better storm proofing your property. Thank you for your time, and now I'll stop and try and answer any questions there are.
Thank you so much, Bill. A lot of really cool ways that we can tell how we can reduce that erosion risk in our vineyards. And there's just one question, Bill. I encourage everybody else, if you guys have any questions for Bill, go ahead and type them in. But somebody's asking if there's any other practices that can be selected for older farmland types, and they're specifically asking for irrigated pasture. This soil loss equation applies to any agricultural setting, right, Bill?
Yeah, Miguel, and you have more experience in other agricultural settings than I do. So if you want to jump in and answer that question, that would be fine with me.
Yeah, definitely. So this equation that Bill was describing is the universal soil loss equation. So this applies to any and all agricultural settings. Obviously, when you are looking at row crops or, for example, like vineyards where you have specifically rows going in a specific direction, that is, as Bill was mentioning, with the different parameters, that's your slope length and your row direction as your practice.